Hi, I'm Medan Shavakla from CSITA section. My topic for the concept video is methods of polymerization. So without any further ado, let's move on to the topic. Agenda today is introduction to polymerization, chain polymerization, step polymerization, graft polymerization, initiator polymerization, and summary. Introduction to polymerization. Polymerization is process of combining multiple molecules into a large combined molecule. This process can be used to create a variety of materials from plastics to fabrics. There are several methods of polymerization, each with its own unique advantages and disadvantages. Understanding the different processes can help you choose the right one for your project. Chain polymerization. Chain polymerization is the most common type of polymerization. It involves the use of a catalyst which helps to initiate the reaction and create the polymer chains. This method can be used to create a variety of polymers from polythene to polyester. It is also relatively inexpensive and can be used to produce large quantities of the material quickly. What is chain polymerization? Chain polymerization is a method of creating polymers from monomers. It involves the addition of monomers to a growing polymer chain, resulting in a long chain of molecules. This process is used to create a variety of materials such as plastics and synthetic fibers. Chain polymerization can be either step growth or chain growth. In step growth polymerization, monomers react to form dimers, trimers, and other multi-unit molecules. In chain growth polymerization, monomers add to the growing chain one at a time. Advantages of chain polymerization. Chain polymerization has several advantages over other methods of polymerization. It is a fast and efficient method, allowing for the production of large quantities of polymers in a relatively short amount of time. Chain polymerization also allows for the production of polymers with a wide range of properties and characteristics. Chain polymerization is also relatively easy to control. The reaction can be stopped at any time, allowing for the production of polymers with a specific molecular weight. This makes chain polymerization an ideal method for the production of polymers with specific properties. Disadvantages of chain polymerization. Despite its advantages, chain polymerization has also some drawbacks. One of the main disadvantages is that it is an exothermic reaction, meaning that it produces heat as byproduct. This can be dangerous if not properly controlled, as it can lead to explosions of fires. Chain polymerization also requires the use of initiators, which are chemicals that help to start the reaction. These initiators can be toxic and contaminate the final product if not properly managed. Applications of chain polymerization. Chain polymerization is used in a variety of industries, including the production plastics, synthetic fibers, and rubber. It is also used in the production of adhesives, coatings, and paints. Chain polymerization is also used in the production of pharmaceuticals and medical devices. Chain polymerization is also used in the production of biodegradable plastics, which are made from the renewable resources such as cornstarch or sugarcane. These plastics are more environmentally friendly than traditional plastics, as they can be broken down by bacteria or other microorganisms. Safety considerations for chain polymerization. Due to exothermic nature of chain polymerization, it is important to take safety precautions when working with it. Protective equipment such as gloves, goggles, and lab coats should be worn at all times. The reaction should also be conducted in a well-ventilated area away from any flammable materials. It is also important to ensure that the initiators used in the reactions are properly managed. Any unused initiator should be controlled in a safe place and any spills should be cleaned up immediately. Proper disposals of initiators and other chemicals should also be practiced to avoid the contamination of the environment. Step polymerization. Step polymerization is a type of chain polymerization, but it involves the use of two or more monomers. This method is often used to create materials with specific properties such as strength or flexibility. This process is more complex than chain polymerization and requires more precise control of the temperature and pressure. However, it can be used to create unique materials with specific properties. Introduction to step polymerization. Step polymerization is a type of polymerization process that occurs when small molecules are joined together to form a large polymer chain. This type of polymerization is used in a variety of industrial applications, such as the production of plastics, coatings, and adhesives. Step polymerization is a type of chain growth reaction, meaning that the polymer chain grows in length as new monomers are added. The process is initiated by a catalyst, which can be either chemical or physical agent. The monomers are then added one at a time, and the catalyst helps to speed up the reaction and increase the rate of polymerization. Types of polymerization. There are two main types of polymerization: free radical polymerization and cationic polymerization. Free radical polymerization involves the use of free radicals, which are highly reactive molecules that can initiate the polymerization reaction. Cationic polymerization, on the other hand, involves the use of cations, which are positively charged ions that can also initiate the polymerization reaction. Both types of polymerization involve the addition of monomers to the growing polymer chain. This is a process known as chain growth polymerization, and it is the basis for the production of many types of plastics, coatings, and adhesives. Applications of step polymerization. Step polymerization is used in variety of industrial applications, including the production of plastics, coatings, and adhesives. It is also used in the production of elastomers, which are materials that can be stretched and then returned to their original shape. Step polymerization is also used in production of biodegradable plastics, which are made of which are made from renewable sources such as cornstarch or sugarcane. Chip polymerization is also used in the production of nanomaterials, which are materials with extremely small particle sizes. These materials are used in a variety of applications, including medical devices, electronics, and optics. Advantages of step polymerization. One of the main advantages of step polymerization is that it can produce polymers with high degree of control over their properties. This is because the polymerization process can be tailored to produce polymers with specific properties such as strength, flexibility, and durability. Step polymerization is also relatively fast and efficient, making it a cost-effective production method. Another advantage of step polymerization is that it can be used to produce a wide range of polymers with different properties. This allows manufacturers to create polymers that are tailored to specific applications and requirements. Additionally, step polymerization is a relatively safe and environmentally friendly process as it does not produce hazardous byproducts. Disadvantages of step polymerization. One of the main disadvantages of the step polymerization is that it can be difficult to control the properties of the resulting polymers. This is because the polymerization is a complex and can be difficult to control. Additionally, step polymerization can be relatively slow, making it less efficient than other polymerization processes. Another disadvantage of step polymerization is that it can be costly as it requires the use of catalysts and other chemicals. Additionally, the process can generate hazardous byproducts which must be properly disposed of. Finally, step polymerization can be difficult to scale up as it requires precise control over the polymerization process. Graft polymerization. Graft polymerization is a type of step polymerization that involves the use of two or more monomers. This method is used to create materials with a specific shape or structure. This process is more complex in chain of step polymerization and requires more precise control of the temperature and pressure. However, it can be used to create unique materials with specific properties. Introduction to graph polymerization. Graph polymerization is a technique to create polymers with desired properties. It involves the insertion of tailed polymer into another polymer chain, creating a graph structure. This process is used to create materials with desired strength, flexibility, and thermal stability. Graph polymerization is an important tool in the field of material science, as it allows for the creation of materials with unique properties. This can be used to create materials with improved strength and durability, as well as materials with increased thermal and chemical stability. Types of graph polymerization. Graph polymerization can be divided into two main types: step growth and chain growth. Step growth polymerization involves the interaction of two monomers, while chain growth in polymerization involves the addition of two monomers to an active site on polymer chain. The type of graph polymerization used depends on the desired properties of the material. Step growth polymerization is generally used for materials with high strength and flexibility, while chain growth polymerization is used for materials with increased thermal and chemical stability. Advantages of graph polymerization. Graph polymerization has several advantages over traditional polymerization techniques. This process is faster and more efficient, as well as more cost effective. Additionally, the resulting materials are more durable and have improved properties such as increased strength and thermal stability. Graph polymerization also has the potential to create materials with unique properties, such as materials that are both strong and flexible. This makes it an invaluable tool in the field of materials science and has the potential to revolutionize the way materials are designed and manufactured. Application of graph polymerization. Graph polymerization can be used to create materials for a wide range of applications. The process can be used to create materials for medical and industrial use, as well as materials for consumer products. Graph polymerization is also used to create materials for aerospace and automotive applications. Graph polymerization is also used to create materials for clothing and footwear. The process can be used to create materials with improved strength and flexibility, as well as materials with increased thermal and chemical stability. This makes it an ideal tool for creating materials for a wide range of applications. Limitations of graph polymerization. Graph polymerization has several limitations. The process is expensive and time consuming, and the resulting materials are often expensive. Additionally, the process is difficult to control. and the resulting materials are often not as strong as durable as traditional polymers. Graph polymerization is also limited by the availability of monomers. The process requires specific monomers, and if those monomers are not available, the process cannot be used. This limits the potential application of graph polymerization. Initiator polymerization. Initiator polymerization is a type of chain polymerization that involves the use of initiator molecule to start the reaction. This method is often used to create materials with specific properties such as strength or flexibility. This process is more complex than chain polymerization and requires more precise control of the temperature and pressure. However, it can be used to create unique materials with specific properties. Specific properties. Introduction to initiator polymerization. Initiator polymerization is a process in which monomer molecules is converted into a polymer. It is process that involves the addition of initiator molecules to the monomer molecules when which then break the bonds between the monomer molecules and form the polymer molecules. Initiator polymerization is used in a variety of industries such as the production of plastics, paints, adhesives, coatings, and other materials. It is also used in the production of pharmaceuticals, cosmetics, and other products. Types of initiated polymerization. There are two types of initiated polymerization, free radical and ionic. Free radical polymerization, a free radical initiator is used, which breaks the bonds between the monomer molecules and forms the polymer molecules. In ionic polymerization, whereas an ionic initiator is used, which forms an ionic bond between the monomer molecules and then forms the polymer molecules. The type of initiated polymerization used depends on the type of monomer, the desired properties of the polymer. For example, free radical polymerization. Polymerization is often used for polymers with high strength and heat resistance. While ionic polymerization is often used for polymers with low melting points and high flexibility. Advantages of initiated polymerization. Initiated polymerization has many advantages over other types of polymerization. It is a fast process with high yields, and it can be used to produce polymers with a wide range of properties. It is also a relatively inexpensive process and can be used to produce large quantities of polymer quickly. In addition, initiated polymerization is a relatively safe process as it does not produce any hazardous byproducts. This makes it an attractive option for industries that require large quantities of polymer in a short amount of time. Disadvantages of initiator polymerization. Initiator polymerization has some disadvantages as well. It is relatively complex process and requires the use of specialized equipment and chemicals. In addition, it is not suitable for all types of monomers as the initiator molecules may not be compatible with some monomers. Initiator polymerization also produces byproducts that can be difficult to remove from the polymer. This can lead to contamination of the polymer and can affect its properties. Finally, the initiator polymerization can be an expensive process as it requires specialized equipment and chemicals. Applications of initiator polymerization. Initiator polymerization offers a range of applications in industries such as plastics, paints, adhesives, coatings, and other materials. It is also used in the production of biodegradable plastics, nanomaterials, pharmaceuticals, cosmetics, and other products. Conclusion. Uh, Polymerization is an important process for creating a variety of materials. There are several methods of polymerization, each with its own unique advantages and disadvantages. Understanding the different processes can help you choose the right one for your project. By understanding the different methods of polymerization, you can make an informed decision. You can make an informed decision about which one is best suited for your needs. About which one is best suited for your needs. Understanding that? Yes. With the right polymerization process, you can create a variety of materials with specific properties. Huh? Summary. Polymerization is crucial process in production of materials. Addition and condensation polymerization are the two main types of polymerization. Other methods include emulsion polymerization, suspension polymerization, and solution polymerization. And in this PPT and concept video, I have said polymerization more than anyone in this world right now. Thank you. Peace.